Hello, I will explain viewing strategy in this tutorial. As you can see that I have an entrance hall modeled here in Rhino, and I already referenced some points. Now I'm gonna use these points to get references from my entrance building into the parametric definition. For that, I will just create point and then reference my first point over here. Yeah. So for the viewing strategy, we need to first of all define the positions of the columns. So this depends on your design, obviously. And let's start creating a position for my first column. I want to create it close to the entrance. So here is the entrance door, and this is the elevator door, and then this is the entrance space. So I would like to create the first column next to the entrance, but of course I don't want to block the entrance. So I would like to create it somewhere over here, and then I can define maybe a sitting element attached to that column, or this column can also define a space for people to meet or wait. Let's define the boundaries where this column could be created. So I have here the first point, and I don't want to go over here, so let's define maybe the middle point of this left-hand side wall. So for that I will quickly write a parametric definition. I don't want to measure all the distances and then give correct dimensions, but I can parameterize it by referencing these points. So just double clicking the canvas and then line. This is the component that this component will create a line between 2 points, and I want to get the middle point, curve middle, that it takes a curvilinear or linear geometry and then calculates the center point. So then we basically have the 2 points, and I need move and how far this boundary should be. I don't want to block the entrance, so then I should calculate the distance between the trace of this entrance. I can just quickly distance measure it. And it is 105 centimeters. centimeters. And I would like to move this points along the x-axis from the positive side, so unit x, which is defines a vector along the x-axis. So this is the value, and yeah, here you see that I have points that boundary conditions for the position of the first column. So you can label this this small definition by grouping and then writing boundary first column, and then add this name to the group. We need to define a point in this boundary, and it can be random, but it should be in this boundary. So for that we have a component called populate that basically takes a two-dimensional region and populate points in it, and in this case we just want to populate one. And it asks first reference region. So if we can create a surface from these 4 points, we can use that surface as the region. So let's input the first point, the second point, so we have here a list of points. So we need to define one by one. Therefore, I use the list item. I select the first item in the list, which is over here, but we're looking for the other point that is close to the midpoint over here. Otherwise, our surface would not be created correctly. So the points should follow each other. And so if it's the first item, we are looking for basically the second item in the list. And then this is going to the third. And the first item should be the last. And now we created the region. Just plug this in. And yeah, we created a point over here. And as we gave 1 in this count, that we only created 1, if we change it to 10 points will be populated randomly inside of this boundary. So you can randomize it by using the seed. Let's give 10 and use this as a seed. So yeah, you basically you see different positions. You can select whichever you like. Let's select this one. For the second column, we will use a similar logic that first create a boundary from these 4 points and then populate the position. Let's go and surface 4-point surface, and then let's reference our points this time, starting from here and one by one selecting the points. Set one point, which is this one, and the last one, and populate and enter, and yes, one, use the same seed. Okay, now that we created the positions, we can define the column-based geometry. So we go to circle and then base point and the radius. Let's say the radius in this case could be half of the distance between these points, so let's use that division. Set data item 2. So we created the first geometry, the base geometry for the first column. Similarly, we will create the second one, second base geometry. So we defined positions for the 2 columns. And then we need to define the column size. So just array, linear array, the geometry, the direction. Our direction is on the Z axis, so unit Z, and numbers. Yeah, we can give a distance with the directions. So let's say 20, and then how many of them. It's written by default 10, but we can make again some calculations with that. So first of all, let's measure the distance between these 2 points. This distance will give us the height of this entrance hall. So distance, let's get the reference, that first point, and then second point. So we have 300 centimeters. So then we can basically use this distance to calculate how many circles that we would like to generate by this array component. So at the end, this linearly arrayed circles will define the column geometry. So we can basically give the distance over here, that it will, and then if we say, let's say the integer is 2, that it will basically give us two circles 300 centimeters apart from each other. Okay, so at the end that this two circles will define a uniform column. Let's say that we would like to get more customized columns. We can do so that, let's say, this distance. So let's division. Take A as the whole distance and then divide it to 20. And then it will give us distance. Instead of this, we will use that. And then since we defined 2, but we can parameterize that as well by division and taking this one, or just basically maybe writing this one. Yeah. So we define this as 2, but if we go plug this in here, that we define more than. So if we change this one, basically we can densify, or we can change the arrangement of the circles over here. And for the second column, I will show you a different strategy. So for the first one, that we created a surface, and then we randomly define a point in that surface. But we can be more definite than that. Let's say that we get again the reference from the site. So on the left side, measure the distance between these 2 points and then find the middle position. So let's define a line first. Initializing the second point and curve middle. Yes. And then we can define another position based on this middle point and a point that indicates one of the corners of elevator point. So this is the reference point that we get from the corner of the elevator, and then again line. This is just that we are getting a lot of references from the site in order to map the geometric definition to the site. So let's get the middle point again. So that means that if we change something, for instance, changing the length or dimensions of your site, this parametric definition will change accordingly. So you don't have to define another definition, but it will be changed based on your model over here. So you will gain a lot of time when you're designing. This middle point will indicate the center point for the second column. We don't need to populate geometry, we don't need to define a surface. So this is another way. Let's copy this part. This will be the same. And then input this point instead of the previous one. And then we have exactly the same column over here. So let's group this. Add this part into the group. And ungroup this part of the definition as well. And name it as second column. And then add this name into the group as well. Yes. And so we need to define a boundary for the ceiling in order to indicate the area of the ceiling. I will use polyline component. So this component will calculate a polyline, either a closed or an open one, based on the vertices. So let's create our point list, our vertices list, and then right click on that point, set multiple points. We can actually just by clicking set and enter, and then we create this point list. It's important that you select all the points in an order, otherwise the surface or polyline will be created differently based on the order you have given. So let's give this list of points as inputs for the vertices, and then you can see that the polyline is created, but it's open. We don't want that. We want to define the whole rectangular area, whole rectangular boundary in here. So for that we need to right click on the node of C. So it's a boolean. We set instead of false, we set it true. So now our polyline is created as a closed one. So this is the ceiling area. So in order to create a viewing structure, first covers the whole ceiling, and then it will kind of sucked into these funnels, which are our columns. So let's group this as well and write ceiling area add this name into the group. Okay, now we will loft the curves of the columns and the ceiling boundary, which is a rectangular curve or polyline. First of all, you need to orderly input the curves. So it will start from the ceiling curve and then clicking Shift and clicking this node, the geometry. Yes, let's see what happens. So you see that this loft component ignored the curve of the ceiling, which is why this geometry lists of circles. So list in list. First of all, we need to flatten that. Now we have a list of circles instead of list in lists, so tree structure. So this is an simple list. And then again, first seeing the ceiling area and then the list of circles. Yes, this is not indeed what we want. We would like to have the ceiling first start over here, the surface area, and then the kind of sucked into that column or funnel. This is the opposite what we want. So this happens because probably the list starts from here. So the first element of the list is the circle that is on the ground. Let's see if it's correct. List item. Yes, indeed it is correct. So this list should be reversed. So by right-clicking on the output here in the flatten component, we can reverse it. And now you see that the first element this time is the one which is close to the ceiling. And now we should see at least it's the correct order. But you see that the loft is a little bit uncontrolled. So for that, we need to define loft options. So I will show it to you. We don't need this anymore. Loft options. So go enter search keyword of loft options here. And you see there are a bunch of preferences, inputs that you can give. So just let's click this into the options and see. So first of all, it's asking if it's a closed loft or not. It is not close to loft, so it should be false, which is correct in this case. We can adjust, so adjust the loft. Yes. So then you see here that the weird kind of surface is cleared out. So it's more controlled. We adjust it. Now we can rebuild, which means that we set more, which means that we can more precisely define this loft, this surface. So let's give 100 and then refit. So it says tolerance Let's make it 10. And the type of loft, let's keep it normal. Okay, now we have much more controlled surface, and then this is indeed what we want. There is this surface over here that indicates ceiling, that covers ceiling, and then transforms into a funnel, which is the column. We want this part will be fitted into the ceiling, and we don't want it going beyond, or it's going higher than the ceiling itself. Clean some of this circles. Let's say instead of 5 elements, we can keep this 3, and then we can delete the first and the second item. For that, we can use this cal index. This component will take a list. So in this case, let's work in the simple list, which is the flattened one. So let's take this one, and then by right-clicking indices, set multiple integers. So we would like to delete the first item and the second item. So their index numbers are 0 and 1. Commit changes. And now we have our new list, which is this 3 items left. And then instead of the whole list, let's give this simplified list into the calculation of loft. So first of all, this should go first, and then these ones. Yeah, we need to flatten again. So this shape looks okay. So we need to indicate the second column as well. Let's use this similar definition, copy paste it, and I use it over here. And 3 elements. So basically we created the surface that we will work on. The next step is to create the positions for the stripes or for the beams to be woven into each other.